how many tests do we have to write to thoroughly test this algorithm? The answer is in close relation to cyclomatic complexity metric. The theory says that we can write one test case for each independent path through the control flow graph. That is a path coverage testing strategy. In practice, however, this strategy is often not easily applicable, especially when units larger than a single method are tested. Number of independent paths then may grow too large. Similar strategy is branch covering. In that strategy, we attempt to cover all branches. Number of tests is then typically lower than the cyclomatic number of the algorithm. So let's see what numbers could be passed through the algorithm to cover all paths. The first path through the algorithm is impossible to reproduce. It would require a single-digit number which is equal to 10, which is a contradiction. The second path is easy to reproduce. Number 3 walks through this branch. The next path we need to cover is the one for a 2-digit number which yields 10 after the modulo operation. Number 31 walks this path and it produces control digit 1. The last, fourth path is traversed for a 2-digit number which yields modulo 11 different from 10. For example, number 42 covers this path. Starting from the cyclomatic complexity metric, and by rejecting one impossible path during the process, we have designed a set of 3 independent tests that are covering all possible execution paths through the algorithm. But, as said before, it is possible to cover all branches in the algorithm without necessarily covering all paths. For example, the last 2 tests are covering all branches in the control flow diagram. With these 2 tests in place, there is not a single branch in the algorithm left out. With branch coverage strategy, we are covering all exits from all decision blocks, and that may be sufficient.